Last time we talked about how to find vertical asymptotes, and today we're going to talk about how to find horizontal or oblique asymptotes. Now, the way this one works is you actually do division. It's all about long or synthetic division. And yes, there's this nice little chart, but really, if you just know how to divide, you'll be fine. This chart's just saying if the degree is smaller on top, then your horizontal or oblique asymptote is always y equals 0. That's because if the degree is smaller on top, you actually can't divide them any further. And so you're already at a remainder. So you have the top number goes into the bottom number 0 times. And I should note that it's essentially division. We just get rid of the remainder, and that's how it works. If the degrees are the same, then it's just a over b, where it's just the coefficients. So if I, like for instance, I had 2x squared plus 1 over 3x squared plus 4. If you divide those terms, 2x squared divided by 3x squared, that's just 2/3. That's what y equals 2/3 would be our horizontal asymptote, if I could think. Sweet. And then the last one is where the degree is actually bigger on top. That's where we're going to have something in the form y equals mx plus b. That means it's actually oblique. Oblique just means it's slanted. And you have to use synthetic or long division to finish solving it. So I'm going to show a quick trick on all of these so you remember which one's which, or hopefully you remember which one's which when it comes to our problems. So we are, and also just as a side note, we're going to also find y-intercepts. That wasn't on the main page, but let's review that. I'm going to go back. To find a y-intercept, just remember you're plugging 0 in for all the x's. So pretty easy. We've done it a few times this year already. So let's go ahead and find horizontal oblique asymptote first, then we'll find y-intercept. Now this should say y equals. That's a typo on my part. But when it comes to horizontal oblique, what you do is you look at the first term, if it's in standard form, of the top and the bottom. And you're going to go ahead and just divide them. So 5x squared divided by 3x squared, that does simplify, and it simplifies down to 5/3. If it simplifies down to something with no x's, that's automatically your answer. And that means it's going to be a horizontal asymptote. Y-intercept, like I said, we're going to plug 0 in for all of our x's. So for the y-intercept, I'll do y is equal to 5 times 0 squared over 3 times 0 squared minus 0 minus 4. Well, that's just 0 over negative 4, which equals 0. So our y-intercept will be at 0, 0. Let's go ahead and do another one. Okay, horizontal or oblique asymptote. So I'm looking at those first terms again. So that's for my horizontal or oblique. Since it's smaller on top than the bottom, so this one's bigger, that means it actually will not divide, and your answer is automatically y equals 0. Let's do our y-intercept. For our y-intercept, and remember once again this is supposed to be y equals. So for our y-intercept, we have y is equal to 0 over 0 cubed minus 8, 0 over negative 8, or once again 0. So our y-intercept is again at 0, 0. But don't worry, it'll get more exciting for y-intercept later. Okay, let's go back to horizontal or oblique again. Once again, look at the first terms and divide them. Once again, this is smaller on top, and this one's bigger. That means our HA/OA, I'm going to just write it this way, so horizontal or oblique asymptote would be y equals 0. And that's because if we did x squared over x cubed, that's 1 over x. That means we're already at a remainder, so it's just y equals 0. So that's that. Let's go to y-intercept. So y-intercept, I'm going to go ahead. Remember, this is supposed to be y equals, because I forgot to do that when I put all this together. So it's 0 squared minus 1 over 0 cubed minus 2 times 0 squared minus 9 times 0 plus 18. You'll notice a pattern, by the way. Because you're putting 0 in for all the x's, really you can just look at the constants, so negative 1 over 18. So the constant of the numerator over the constant of the denominator, and that will tell you your y-intercept, just so you know. So our y-intercept is at negative 1/18. So we put 0 in for x, and then we have negative 1/18, like so. Let's keep doing a few more, just get some more practice in. Okay, so for this problem, we're going to do our horizontal or oblique asymptote first. We're going to look at those first terms. And our first, so this one's going to be an oblique because this would give us y equals 2x. So we're missing the constant, so we're going to do long division or synthetic division. To find that. Now remember, we don't need the remainder, so we're not going to go through the whole process. This is going to be an oblique asymptote. I'm going to take the 0 of the denominator. So I'm just going to make a little note right here. That's where we got that. And then we're going to put our constants. So we've got 2, negative 1, and 0. And we're going to make our thing, and we're just going to drop that 2 down. 2 times negative 2 is negative 4, and we'll add. It's negative 5. We don't care about the remainder, so once I get to this, I'm done. And I will change that to a minus 5, and that will be our answer. So let's go to y-intercept. Y-intercept, just going to plug x in for all the zeros. Or sorry, plug 0 in for all the x's. That was gibberish. So on the top you end up with just 0 because that's the constant on top. The constant on bottom is 2, so 0 over 2 is 0. So we have a y-intercept at 0, 0. I've had a lot of 0, 0 y-intercepts. This is another one. Let me see. Oh, good. We've got some that are not 0, 0 coming up. Let's do one more and then we'll do some graphing. So, once again, horizontal or oblique. You just divide those. So 3x cubed divided by 2x cubed is just 3 halves. So our horizontal asymptote is y equals 3 over 2. And then y-intercept, you're going to look at the constants as that quick trick. So y is equal to 0 over negative 16, or just 0. So our y-intercept is at 0, 0. Let's do some more exciting ones in a second.